you get to hear me now.
Do some warm-up problems. We have 4 right here. They're very simple, but we're gonna do them anyways. So the tangent of 11 pi over 6. So when you look at the unit circle, and we have an x and y coordinate, and each quadrant has 3 points. Actually, I'm gonna make the middle point a different color because it's part of a different family. So whatever I do in red is away from one another by pi over 6, and whatever I'm going to do in blue will be away from one another by, well, from each other, the points, from each other, the points as far as I'm concerned is pi over 2, but from the axis, they're away pi over 4. Okay, so tangent of 11 pi over 6. We are talking about this location right here. The reason why I know that's because it's only pi over 6 shy from being 2 pi. So when you do this, you're going to end up talking about tangent. Tangent is typically y over x. So when you look at y over x, this coordinate is, it's very far to the right, so that is square root of 3 over 2. And it's very low down. It's not that far down, so that is negative 1/2. So negative 1/2. So y would be negative 1/2 over square root of 3 over 2, which simplifies to be negative 1 over square root of 3, or square root of 3 over 3 with a negative. Bam. Let me do another one. Cosecant. By the way, you should have tried this before looking at me doing this, just to see how good you are. So cosecant is 1 over sine of pi over 4. Pi over 4, the sine is square root of 2 over 2. I know this because the blue ones, they're usually either positive or negative square root of 2 over 2. So the location is key. Because it's in the first quadrant, this will be square root of 2 over 2 for the y or the x. Cosecant is 1 over sine, or, as far as the unit circle is concerned, 1 over y. So that right here will be 1 over square root of 2 over 2. Oh my god, that looks bad. Alright, and so that would be 2 over square root of 2, which ends up being square root of 2. Alrighty, let me just circle these bad boys. Secant is 1 over cosine, 5 pi over 3, so that would be 1 over cosine of, and I'm going to rewrite it as 10 pi over 6, because that's what it was originally. These are typically referring to the red points, where this is 11 pi over 6, this bad boy was 11 pi over 6, so we're talking about this one. So the x coordinate of that is 1/2. It's to the right, so that's 1/2. It's very far down, so the y coordinate would have been negative square root of 2 over 2, negative square root of 3 over 2. But because we're talking about cosine, that's the x, so that would be 1 over 1/2, which is 2. And then the cotangent, I'm going to let that be a bonus for you guys. Spoiler alert, it is going to be 0. Anyways, let's continue. Please write this down. This is the objective. You're going to need this in your notes when I check it. Alrighty, what's a limit? A limit is the surrounding at a certain point, or the y-axis, or the height of a function. But we don't care about the point itself. We only care about the surrounding areas. And we're going to do some examples. Let's look at 7. The function at 7 doesn't actually exist because you can see an empty dot. So when you have an empty dot or an open dot, that means that the value that doesn't, and as far as the domain is concerned, 7 doesn't exist. And because 7 doesn't exist for a function, there shouldn't be a y either. So it doesn't really exist. So f of 7 does not exist. But that's not relevant for the limit, because limit we're just talking about the surrounding. So when you follow the function from the left and you also follow it from the right, it approaches something, and in this case it approaches -1. So the limit is kind of only worried about the surrounding neighborhood of the point, infinitely close, but it doesn't care about the point itself. When it comes to 10, let's look at 10. We have the function does exist, and it also would have approached 3, so the limit as x approaches 10 would be 3. So please get these values right here. I want to see them in your notes. Okay, so let's do the limit as we approach -6. So -6, we're talking about this region right here. So as you approach -6, we notice that the function does exist and it approaches 1. So the answer is, the limit is 1. So the height is 1. And then when we look at 5, as you approach 5, we are approaching, as we approach x equals 5, we're approaching the value 4. So this one would be 4. When we talk about limits, we also can talk about a specific direction. So if you see number 1 and number 2, number 1 we're talking about approaching 0, and then you see a plus. And that means that we're approaching from the right side. So when we look at approaching 0, we are specifically saying approaching this bad boy from the right side. So even though you would say that there's no neighborhood on the left side, we're not talking about the left side, we're only talking about the right side. So the answer would be 0. So let's get out of here. Boom. Let's zoom out real quick. So the answer would be 0. When we talk about number 2, we're talking about 0, approaching 0 from the negative or the left side, and that is a different answer because we are approaching, let me use green, we are approaching from the left side, and that answer will be 4. So the number that we're approaching is the same, but it makes a difference when we have a discontinuity like this, whether we approach from the right or left side. Approaching from the right gave us 0, approaching from the left gave us a 4. For number 3, we are approaching 0 from both sides, and because they don't match up, they're not the same one, over here you can simply say the limit does not exist. The condition for limit to exist is that the limit approaches the same number from both directions. So that's a pretty good example. So number 1, 2, and 3 definitely needs to be in your notes. It all needs to be in your notes, but this is groundbreaking information right here. This pretty much talks about the definition of a limit. So approaching 3 now, you can tell that that one doesn't exist either. Because if you approach from the left side, and let me zoom in, approaching from the left side would give you 2, but approaching from the right side would give you a -1, and 2 and -1 are not the same thing. Therefore, it does not exist. Okay, let's continue. Alrighty, so please pause the video and try these numbers, and I'm going to do them in a bit. Let's see if you get the same thing. Alrighty, -8. -8, the function would equal -3, but we're talking about what we're approaching. So the answer would be -6. For number 2, the function would have given us 5, but the limit, we're talking about the surrounding, does not exist, since on the right side, coming from the right would give us 5, coming from the left would give us 2. So since the two disagree, it does not exist. When we don't have a limit, we're talking about the actual value. So the actual value is actually right here, which would be -3. It's very important. When we talk about f, we don't care about the neighborhood. We don't care about surroundings. We only care about the specific point. And over here, the specific point, f of 8, -8, does equal -3. So let's continue at -2. So we're talking about limit. Over here, we're talking about the limit as x approaches -2. Again, there's no right side, so there's, there's a right side. I probably just have to move up, don't I? Nope. Well, it doesn't really matter. I don't know what that's up to, how far we go up, but it doesn't. That's not important. There is no right side as far as I'm concerned, so that's going to be a does not exist because you only have the left side, if you know what I mean. So over here we're approaching 10. Approaching 10 from the left side and the right side would give us a 0. And then what's the function at 6? F of 6 is 5. Because there's a solid point. This is a hollow point. So not as far as the domain is concerned, 5 exists up here and it does not exist down there. Alrighty, let's continue. When we evaluate limits, there's some techniques that we use. There's substitution. This one is we just substitute for x. There's factoring. We may need to simplify it. The conjugate method, that's when you happen to have radicals on the bottom and you're trying to, when you end up getting a 0 on the bottom and you can't really do that kind of stuff, and you have a radical as well. The conjugate method is a good way to fix that, or you can multiply by the least common denominator. Alright, so let's continue. So here's some examples. For the number 1, we just kind of plug it in because we can. So when you plug in a 2, we end up getting 2 cubed minus 2 squared minus 4, which should give you 0. For number 2, we plug in 2 pi over 3, which I prefer to call 4 pi over 6, because I know what that means. It's, as far as the unit circle is concerned, we are located right here, with the x being -1/2 and the y being square root of 3 over 2. That way I don't need a calculator, pretty much. So when you just plug it in, you multiply that by 2 again. So that ends up being 8 pi over 6. So 8 pi over 6, that's located right here, if I'm correct. We are right here. So a cosine, would have been the same thing if you double it seems. So the cosine for that one would be, they ended up getting 1? Oh, because you multiply by -2. Well, the cosine ends up being -1 over 2, but then when you multiply it by -2, you end up getting 1. So over here we just substitute in. There's when you substitute, you just do, and you end up getting the values. For the last one, when you do 2 cosine of 3 pi over 4, that is negative radical 2. Over here is an example when it's not that easy, because if you were to plug in 2, you'll end up getting a 0 in the denominator, and you can't do that. You end up getting an undefined function. But the top, as you can see, this is factorable, because two numbers that multiply to give you 8, but when you add them, you get -6, will be -2 and -4. So you can create these factors. We happen to have a x minus 2 on the bottom as well. You cancel them out, and now we're at a point where we can just substitute in. 2 minus 4 is -2. Alrighty, so here's some practice problems for you. So go ahead and try these out and see what you get. I'm going to do them in a second. Alrighty, hopefully you paused the video and you attempted them. So from the graph, we see that as x approaches, number 1, as x approaches 3, we have -2. So that answer is -2. And number 2, if we approach 0, that would be -1. Number 3, we approach -3. We would end up getting the 3, I'm assuming, by the way, that these are all scaled. So -1, -2, -3, so that would mean that that's 1, that's 2. My 1s and 2s are horrible. That's 1, that's 2, that's 3, that's 4, that's 5, that's 6. So that's how I get these values. Alright, number 4. So we approach 1 from the positive side, which means that we have a 2. We approach 1 from the negative side, we end up getting -1. We approach 1 in general, so it does not exist because the positive and negatives don't match up. Approaching 2 from the negative, we end up getting 0. Approaching 4, we end up getting negative. We don't have a right side though. Almost fell for that, so that one does not exist. Here's why. There's only the function exists, but there's no limit on the, so if it would have showed something like this, it would have been fine, but because we don't have that, it does not exist. That's because there's no right neighborhood. For 2, we are right here, so that is 0, and 2 from positive side doesn't matter because it's a continuous function, so that's 0 as well. Alrighty, hopefully you got the same things as me. In case you didn't hear what I said, at 3, that ended up being -2. Even though the function of 3 is different. If you would have only asked for the value at 3, it would have been 1. And then at 0, that's -1. And for -3, that is 3. Alrighty, good job if you got them right.